Well, hi, good morning. Thanks for joining me here in my shop with me and my cat. And I'm going to take another run at trying to figure out why the local oscillator isn't working on the higher bands on this radio. Radio's not on, there's no beat plus, tubes are cold, it hasn't been on yet at all. But the sound you were hearing is being picked up by the audio cable from the ground connection to my SDR. Why it is doing this much noise, this is all audio. You'd swear it's a radio you're listening to, but I don't get it exactly. But there's lots of stuff I don't get when I'm in here. So for now, what I'll do, just to avoid all that noise, I'll just leave the ground off. This is just an antenna going to my SDR, and it's just clipped onto the insulation of this wire, which carries the oscillating signal all the time. Well, when it's operating anyway. That should be enough to have something show up on the SDR. My approach here today, I've been trying to think of what am I going to do here. I'm pretty much run out of ideas of how to even investigate this effectively. So what I've got in my head now is I'll turn the radio to the highest band. It still produces a local oscillator on, and then I'll mess around with it because I can see the strength of the local oscillator while I'm doing that, one way or another, maybe on my SDR or however I want to do it. And maybe that'll give me some insight into what weakens and strengthens the local oscillator. And so maybe I'll figure out what I should do about the two bands that just won't break into oscillation at all. That's my approach. So first we got to get the radio operating. Make sure it's on the broadcast band. Volume's down. Heater's on. Okay, my cat, you stay right there, okay? So my cat's fairly famous. There's an article in the local paper about her, not by name, and it's from a neighbor of mine. My neighbor 4 doors down is doing everything he can to ensure that this cat never goes outdoors again. That's what's happening. It's winter now, she's not going out, so it doesn't really matter, but he's approached all the authorities. All the authorities have told him there's nothing that can be done. You just have to protect your property from a cat, a wandering cat. And that's not good enough for him. So he's approached all the authorities, and the last thing he's done is he's gone to the local paper. And they have quite an article about my cat here. Poor cat. Look at her. Isn't she a vicious monster? The vicious monster in the neighborhood. Ruining the lives of my neighbors, apparently. Okay, don't want to get too far into that. We should be all warmed up here. Let's turn a little volume up. We shouldn't hear anything because there's no B plus yet. We don't hear anything. Okay, so now I'm going to bring on the B plus. Okay, it should show up on this meter still. And we're aiming for, let's see, just make sure this. So I'm going to clip this onto the plate of the oscillator. We're going to make sure the voltage on the oscillator gets up to 175, which is where it is supposed to be according to the... Now I can pick it up here. So this will pick up the plate voltage here. Volume's up everywhere? No, not everywhere. Okay, so we should hear the radio when it comes to life. Here we go. Look at that, 23 volts, and the radio appears to have started. Yep. Oh. Punch the microphone there. Radio down. Get up. So the reason, now let's check something right now. The radio's tuning. So on the broadcast band with 80 volts instead of the 175, the oscillator oscillates. I ran in here last night all excited. I thought, oh my gosh, I know what's wrong. I had never raised the B plus sufficiently to make the oscillator oscillate at those high frequencies. I came in here, turned everything on, got everything going, basically did what I'm doing right now. When I got up to 175, didn't make a hill of beans worth of difference in the radio. top two bands still not oscillating. Okay, well, let's go a little higher here, more realistic. More like 100. Let's stop around here. Okay, so 175 is the proper voltage. We're just a little low on it. And again, seems to be working quite fine. Oh, we should look at the SDR here. Give me a second. So on the SDR over here on the right, you see this tall signal, and you can see its red line down below here. That's the local oscillator. The radio is about mid-band right now. So that would be conceivably around 1,000,000 kilohertz or 1,000,000 hertz. And then the local oscillator in this radio is 460, I think. So you go 1,000,000 plus 460, give you 1,400. So a local oscillator should be around 1,400 by all that reckoning. Look where it is. Now I'm going to fool with the B plus voltage up and down, and we're going to see if the frequency varies. When the frequency varies, if you watch, I'll change my display here. More of this red line here. It's a little bit like the recent history of it. So if I vary it, you can easily see that it got varied. Finding something nice to listen to. Now I'm going to vary the B plus, and we'll watch the frequency of the local oscillator. It's an interesting experiment in itself. I've got to look at two directions at once here. So I don't want to go too high on this. So we'll go up first. 200, and we'll go down. See it move a little bit now. Better look at this other meter here. Okay, so that shows that B plus will move the local oscillator a little bit. That would even go all the way to sensitivity of the incoming AC voltage. If your house voltage is going up and down quite a bit, that could even move the local oscillator a touch. I think it would be a very tiny amount. Okay, so broadcast band, strong local oscillator, everything behaving the way it should, except the local oscillator appears to be way off frequency. Won't worry about that. We'll go to the next band. Okay, sounds like it's operating. We're still looking at the SDR here. So I'm going to go to the frequency involved, just looking for the local oscillator to show up. There it is. I think this is probably here. The band we're on right now is, I'm going to be unsure about it. Oh, did you do something? Yeah. Did you do something? What's that? Audio thing. Dropping to zero and I didn't notice. Okay, back to what we're doing. Tuning to spot the local oscillator. So right now I am tuning the radio upwards in frequency, so the local oscillator should be going upwards. You can see lots of funny lines on here. It's the red one, the one at 57. I believe that would be the local oscillator. So if that is, and everything is working properly, take 5700, subtract 460 from it, you get what, 240. 5240, and I'm going to try to look at the, oh, son of a gun. What's happening here is I'm just moving the radio slightly. You. Something's happening anyway. I'm not spotting what it is. Now, Shadow, help me. What were we going to do? We're going to go to the next band. We are in the next band. We're trying to prove the local oscillator is what we think it is. Okay, let's go back to the SDR. So I'm going to hold something up against the coil. And you should see the local oscillator jumping around. Or didn't it change at all? Oh, there it is. Way over on there. Looks like it may be at 6,300. Tuning upwards. No, it's coming down. No, I go back to the 5,700 one. I'm placing my finger on the coil. I guess it's shifting at a touch. But the other one's all shifting. Where comes mine? So many things. I was going to look at the dial. That's what I was going to do. Okay. Let's take it down. Just turn the radio down a bit here. The dial is, yeah, of course it's backwards in a mirror. Oh, too much for me this time in the morning. Hold on here. Such patience, my little cat. There, you look at yourself in the mirror. Okay, now we are tuned to 6150. So the radio is tuned to 6150. Then I go back and look at the SDR. 6150. Well, it's way the heck up here. So if it's at 6150, then you would add 460 to it. 600. 600. It's not on the screen here. Well, this isn't working out at all. I know that strange thing where the bands are mixed up. Is that where I'm at? And then fortunately the SDR can supply all kinds of signals to look at. So I'm tuning upwards, and that 5700 one just seems like it. Maybe the local oscillator is below. If it's below, then I would take, for instance, 5700, add 460 to it, get 6160. 6160, there's nothing there at all. 6160, that's where the radio's tuned. Wait a minute. Let me look again. You know what? It's right on the money. 6150, 6160, it's right on the money. So the local oscillator is low. I wrote this down before, I'm sure. I've gone through this already. We'll do it again. So this is band 2. Local oscillator below. No, maybe it shouldn't be below. Maybe it's misaligned below. There is some instructions about picking the appropriate peak. There's 2 peaks, and when you're tuning certain items, there'll be 2 peaks. You have to pick the appropriate one, and if you don't, you might get this. Could that in any way be the cause of the local oscillator not oscillating? So in some radios, as you go from band to band, you are adding more and more coil or more and more capacitor, or whatever it is that they're using for the tuning circuit. It's not that you're switching to different coils. You are adding more and more. So the earlier alignment steps affect the later alignment steps. And I guess if you were to do an earlier step incorrect, pick the basically the image side of the local oscillator alignment by accident, then when you get to the higher bands, the situation may be so bad. I doubt it. I just doubt all that. Because let's look at the schematic here. So we look at these coils like this one. hey, this is a stacking. You can see as the switch moves along, when it's in this position, it's selecting all these coils to the ground. But when the switch is finally moved all the way down to here, it's only selecting these. So now these aren't the oscillator coils, but it's a good example. Now it comes in the oscillator coils. So each one has an independent ground connection. It would seem that each one is operating completely independent. So you're selecting a totally different coil. So if you mess up one coil, it really shouldn't stop you from successful alignment with the others. How about this guy? Now this is the this is the broadcast band. I don't know about the local oscillator position on the broadcast band. We're currently on this one. Okay. This one's hooked up to this. This only gets so I'm thinking when this is sliding, this whole bar of pointers is sliding along. Oh, check this out. When you go to the next selection, you're still selecting this because of this. When you go to the next selection, now you've connected this and still have this because these are coming along. So this is an additive thing here. And these are, what are these exactly? I'm a little confused as to exactly what these are. I mean, they sure look like trimmer capacitors. I'm confused because of this and this. So what are these? So there's no hint that this is some kind of trimmer. These look like contacts. And you've got this piece sliding up, hitting these contacts. So these are contacts. But they have a little circle drawn on. Why? Little circle here. Where is a trimmer capacitor? Well, here's one. Here's some more of these contact things. These have a circle on the end. Could be the draftsman just didn't put the circle. Or the circle needs something. To me, it makes these things look like hollow tubes. And there are a lot of trimmer capacitors that are hollow tubes. But this isn't labeled in any way. This is labeled here. There's no indication of an adjustment. So, come to think of it, I always thought, I've been thinking of these as those adjustable capacitors, the tube type. I don't think that's the case at all. These are contacts, and these are capacitors. Now, what side? These all look like pretty small capacitors. 36. They're all picofarad capacitors. There shouldn't be any problem with them, really. But you are adding. As you switch upwards in bands, you're bringing in more and more of this stuff. So this is shown in the broadcast band right now. And none of these coils are involved. The oscillator's being driven with this. It's not quite the right way to say it, but the oscillator's not quite being driven. The oscillator drives things. But you flip the switch up one. You're off this now. This is all out of the picture. What's this? What is this? This is the tuning capacitor. C9, C10, 7 to 22, 11 to, looks like 540. So in this radio, if I remember right, there's a little tiny set of tuning plates in the capacitor. Let me just bear with me here while I try to get my head in the right spot here to take a look. Let's see if that's really the case. Because I see too many radios. Use my mirror. Yeah, that's what's there. So there's 4 sections in the tuning capacitor. One of them is very, very small, just a couple plates. This is probably here, 7 to 22. And so, and what is it doing? It's hooked up. Oh, it's hooked up in here. Very complicated arrangement here to achieve the results they wanted. So when you switch into this band, you now include this additional capacitance. And this is tuned, like you can't tune these separately. So you can think of them kind of like one capacitor. You can't, because they're not connected to the same thing. You can't think of it as one capacitor. So you've got some variation going on way up here, from here, when you get to the next band. And that stays in place for all the rest of the bands as you're picking up these capacitors and switching to these coils. Look at this one. No, this. So when you switch to the next band, this connects to here, and you've got a capacitor for tuning. Well, that's a little interesting, because it looks to me like this. Wait a minute, this is never. Yeah, it is switched here. Oh my God, this is totally mind blowing. So I think this and this are the same switch. Move this up, you move this up. There's no arrow there. Why did they not put an arrow there? No circle, no arrow. Or it's a lousy arrow. I think it's a lousy arrow. So you flip it up. This disconnects. It would seem to be the case. These can't reach all the way to there. They're trying to show you things pictorially here. That's why I'm picking this apart like crazy. You don't know for sure what's in the mind of the engineer or the draftsperson who drew this. So by the time you get to band 2, this is all highly rearranged. Then you go to band 3. Band 3, assumably this connection's not there, and that is for the broadcast. So the broadcast is only connected in the broadcast position, like it's shown in the schematic. You move ahead one, this is all gone. Well, I'd have to look at it more closely to know it's all gone, but it certainly is demoted big time. And by moving it one, you've now switched in this guy. Is this kind of taking the place of this? So what is it? So it's grounded here. We move this up one, so this is now connected. This is all connected together. It's all just mashed together through this connection here. In fact, what is this? This is always connected, isn't it? Well, why use a switch here? This is always connected. Oh, wait a minute. Wait a minute now. This is weird how they show. So this part of the pictorial image of the switch is sliding across these. Well, this guy is still sliding upwards on these. So you're affecting the impedances here with capacitors, a coil, and other stuff, and the engineers got it all worked out. Okay, so that's good. Now we're going to go up to we're at broadcast band, next band working. Is this radio still on beside me? Here it is. It is still. Oh my gosh, are you still listening to it? Yikes. There, just take the hum off. Okay. So now we want to get up to consider what happens when we get to the band that doesn't work. Bands that don't work, and that's this one and this one. So we got to go click, click, click. So we slid this up, click, click, click. We've got all these in now. We haven't gotten to the top band yet, but we have all these in. So at the top band, something else is happening, I guess. So because we're only, how far do we go? We're on broadcast. 1, 2, 3. No, we're all the way to the end when we get to. I'm losing my mind here. We want to stop here. This is the first one that doesn't work. Although look, this one, it's kind of the same deal, coil to ground. This one's the same deal also, coil to ground. So because it works here, but like here, but doesn't work here, I'm gonna get kind of, again, sort of says it's not the problem in the coils. There's nothing wrong in the coils. Everything I've done says there's nothing wrong in the coils. Something wrong with these capacitors. Well, actually, when you get to the second last highest band, you switch in one of these two capacitors. Because I'm a little confused here on just how this one's going. 1, 2, 3, 4. 1, 2, 3. So on the third, it's actually it's the first dead band. This has been switched in. And on the next dead band, this is still switched in. We gotta find this capacitor. C6. No, not C6. This one here. Oh, what is that? 5, 6, 7. Would that be it? 5, 6, 7? That looks like C6 there. Wait a minute. How can that be C6 and this be C6? Huh. Well, well, these all have to be very close together physically because they're all involved in the switch. In fact, they're all got to be pretty easy to track down, really. That's right. The whole time I'm looking at this, I'm thinking of a sliding switch, but it's not. It's a rotating switch, of course. So this is likely to be mounted or attached or coming off of the. It is. It's coming off the switch. Oh, I should be able to find this fairly easily. And I can read that number, 10 picofarads. And this one I can't read. That looks like 10 though. That looks like 96. These are very precise numbers. 10? Parts list. Parts list. Where's the parts list? Parts list. No parts list. No parts list. Okay, well, we'll just have to look and see. Maybe I can, I know how to look at the switch. Did it the other day. Follow the switch thing moving around and eventually sort out. But I think it's just a matter of just looking and seeing this. Okay, let's look and see it. It's going to be in here. And son of a gun, if it isn't one of these, it's going to be one of these precision capacitors again. Maybe not. There's some here. What am I looking for? I'm looking for either a shorted capacitor or a totally open capacitor. Let's ohm them first. And I've done all this kind of stuff, I think, but I don't know how thoroughly I was doing it at the time I was doing it, because I had quite different ideas in my head about things. I'll put this fairly high. 2 megohms. That's what we expect to see right there, just open. And these are all going to the chassis. Double checking the meter. Why is there a negative there? God darn it, Jim, the radio's still on. Crying out loud. Oh my God, what a stupid move. Yeah, let me turn the heaters off too. That was dumb. Dumb. Very dumb. You know the reason? Total silence in here for me. Nothing there to keep reminding me the radio's switched on. Okay, do you think you know what you're doing yet, Jim? Look for a little bit of voltage still being left here. That looks like a 0. That looks like a 0. 0. Right on the supply. A little tidbit. Okay, we're safe. Back to the capacitors. Who is shorted? Who's got a short? Anybody got a short? On the 2 meg scale. Let's do it on the 2 meg scale. Who's got a short? Okay, I wasn't expecting that. Let's try this one. What we're going to do is we're going to clip the ohm meter across that glass capacitor that just showed a short. And then we're going to rotate the band switch and see what happens, because often shorts are switched in on components that are not being used actively in a circuit. What am I doing here? So no, this is supposed to be onto ground. Onto ground. Okay. Check. Wow. Wow. Okay, we'll switch and see what happens. This may be it. This may be the baby right here. So that's staying with a short. These are really nice looking capacitors. You know, it's just kind of far-fetched that there'd be a short. So if these are the capacitors involved, then they are open circuit until switched in. So it's basically a capacitor tied to the chassis and sticking out. There's no circuit to it right now. As I'm trying to validate the test I'm doing, this seems to be extremely valid. Let's try another capacitor. I mean, if the rest all check out, it's a little tricky to get on them here, though. Very tricky. In fact, almost impossible. Let's go this way. Good thing I remembered to turn the radio off. Okay, there's one. Okay, so that shows open. And another one up here. That shows open. And then the one that's showing short is this guy right here. But you know, well, it could be a shorted wire right in there. A fat chance on it, but I gotta pull it away. Okay, so that's the apparently shorted capacitor. And then there's a wire, I can see a bare wire. It looks like it may be in contact. Give me something to yank on. Yank. Give me a yanker. Who's got a yanker here? Okay, don't fool around. Just grab a pair of pliers. Yank away. It's probably not in contact. No, it's definitely not in contact, and nothing happened here. Shorted capacitor. So the next step here is to cut the capacitor lead, and this will be the proof in the pudding. Now, if it turns out it's not this capacitor, I want this capacitor reconnected. So I cut the lead with that in mind. Just tracing the wires through other coils and that. You know what? This particular capacitor is hooked up to this coil here. They're all like that, aren't they? Yeah, I don't know. Let's just do it. Let's do it. Too strong an indication of a shorted capacitor here. Okay, I'm gonna go in. You know, before I cut this, why would I think that's the one? Just because it measured 0. Why wouldn't it be another circuit? I should cut the grounded end. It might be easier to reconnect the grounded end. No, we're going to go up here. Okay, here we go. This is it. If that meter stays 0 after I cut this, then we've got a shorted capacitor. There it is. open circuit. It's not shorted. Okay, I'm going to short it back. It's not the capacitor at all. But it's interesting that there's a short there. Okay, I'm going to leave that capacitor where it is. I'll fix it later. So I'm following the wire there. This is not easy to do. Get a pointer. Okay. So this capacitor I just cut away is connected to a terminal that has a wire on it. It's a bare wire, comes up through here, passes behind the yellow wire here, insulated yellow wire, comes up here, ties to a post on this coil. But then it continues on into you see one of them here, this hole in the chassis and a terminal sticking out. There's another one right over here. So what is up there in the chassis at that point? What is up there? Sorry, Shadow. Well, it's the tuning capacitor. So those are the four. There's four sections in the tuning capacitor, and there's four holes with lead 1, 2, and then 3 and 4. So these are the two. These go to the two that were on the bottom right corner of the schematic. So there couldn't be a short there. I mean, up in the capacitor, it just up in the tuning capacitor. So now we carry on to this coil. Assume, let's see, there's only one. Looks like there's one winding, two terminals. How do you read a short? How much of a short is it? The short is gone. Let me move the clip over to the other side now, because we're actually tracking down the short, which just doesn't seem right. But maybe, you know, I'm on the 2 meg scale here. So that's 0.5. It's reading 0.5 ohms, and my meter's a little cockeyed here. These very low readings are really questionable. Always very questionable. That's virtually a 0. So the lead goes up to this coil, and then the coil goes back into the switch. This is the so, you know, I'm thinking this is the highest band, next band, lowest band, broadcast band. But look, this is wound with two coils. So the physical position of these coils relates to their position on the switch and the order in which these are selected. Maybe not this. This is kind of off to the side here. It's a big coil, busy guy. Maybe he's actually, you know what, the next, assuming you're switching these terminals in order, this one's next, and it's got this capacitor on it. Right, so when we start with the broadcast, first is the broadcast coil. The next is a center tap coil. Maybe that's what this is. I can see a wire down here. And that terminal, you know, it's very likely right on the chassis. In fact, I'm not sure though. So we broadcast. I'm going to call this long wave, and then we get into the 3 short wave bands. These coils look entirely different from these two. On the schematic, they look entirely different too. So earlier I was thinking that the oscillations are, the feedback is from this very hard to see fine wire coil down here. You can see the heavy wire one, but not the fine one in between. Fine wire coil, always emitting the oscillator. And there's enough of a interaction between here and these coils to be the feedback for them. How is the feedback done otherwise? In each band, there has to be a feedback path from the plate circuit back to the grid circuit. So we have, so this band's working, this band's working. I think this one's working. It's these two that seem to be in trouble. Switch the bands here. Watch this thing. Nothing too dramatic, but definitely a change. Oh, yeah. Oh, you can't even see the meter right now. It's okay. Shadow was watching it. Boy, oh boy. So I've gone ahead and proved that all these capacitors are not shorted. I certainly haven't proven their capacitance, but with one disconnected now, I can measure its capacitance. Let's see, we'll use this as a example, if you like, of the rest of them. If this one tests really good, now on it just has a funny number, 1A. 1A. But I think I can find on the I can find a reference to it. Okay. Then we'll know what it's supposed to be. These are supposed to be very precise capacitors. .96 picofarads. Looking at V loss 0. 96 picofarads. 1A, 96 picofarads. Okay, let's go take a look at the schematic again. 96 picofarads. So here's the adjustable one down here. Look at that, 96.3. That's what that looks like. I thought it was this one. No, I don't think it was this one I cut out. The one I cut out appeared to have a short circuit in it. It could be any of these. So it could be this one. Look, this is one switch and you've got it in the circuit. And when I look at the radio, well, who's to say? I can't see enough of the switch to really know what it's doing. For sure. They've depicted it here as if there's two separate bars operating. Who knows how it's really constructed in the switch itself, because they didn't show it as a rotating switch. Okay, so assuming the capacitor I've got there is this one, then it's proving these are all reliable, and I just have so much doubt they aren't reliable. So let's go back to looking here. We're going from broadcast to the 1, 2, 3, and 4 bands. They're all here. So this is the coil, the fine wire coil that's woven inside this heavier wire coil for the top band. But all the time the oscillator signals in here, and just as you see it laid out, it's kind of like that in the radio. As you go down, you get farther and farther from this. This is very closely coupled here compared to any of these others. Like really very closely coupled here, but not here. Probably this is not supposed to generate the feedback here. So what does? So how does the plate signal, which is in this coil, get back to the grid? So plate voltage is coming through here. And the screen and plate are essentially, yeah, that's exactly how the radio is wired. The screen and plate have this coil between them. So if the feedback is not from the coil, what's it from? So we're getting following the plate circuit again. It goes all the way through here, gets to this point. You know, what is this? This is high voltage coming through, 20,000. And there's a capacitor there. High voltage through here, down through here. Capacitor there, and the plate. Oh, we're over to this tube. So I've kind of ignored the possibility that this tube is the cause of the problem, or the circuitry for this tube is the cause of the problem. And no reason, you know, that's an assumption. Let's put it that way. So this can't be the feedback either, because this is open. As soon as you, say, energize this band, this switch is moved up, this is open. And there's a, okay, let's follow the grid back, because it has to get from the plate to the grid somehow. So we follow the grid back. When the broadcast band is operating, the grid is getting this. This is the feedback sort of part. So this is driving this is part is driving the grid, I would say. Wires here, right? Because it has to get to the plate through this other. Well, get to the plate through here. Plate current flowing through here. I think this guy, when you're not using him, he's isolated away and doing nothing related to that. But maybe I'm wrong in that. Maybe there's something going on over here too that has to be made right, even when you're not using the feature. Let's continue on. So if this is the feedback, then this has to be, you know, if this is the feedback from the grid, this has to have plate current in it. This would be up 1, up to 3. This is disconnected now. There's no current in here. So there's no chance of this being the feedback coil. Well, what's this connection here? Okay, so there's another way of looking at this. So this capacitor combination is working against the coils that are selected here. Switches 1, 2, and 3 shown in broadcast position. So this is switch 3. I guess this whole thing is switch 3. Maybe this is front and back. Front and back. Switch 1. And switch 2. And switch 3. So we still are stuck with this idea that this is the feedback route. Plate current going through here, tickling the grid, even at this range. It just really doesn't add up. So, what is it about those two bands that is different from the others? What happened to my idea of getting to the weak band and playing around with it? Okay, so I was chatting with the owner of this radio a little bit. You know, one of the things about it is I don't have the speaker for it, and I've been powering it from shop supply and that. So he's going to try to get the speaker over to me, and then with the speaker I'll be able to power the radio from its own power supply. And that may solve the situation. Now, the thing is, where I live here in Ontario, in Canada, the government has just announced a stay-at-home order. And so we have literally been ordered to stay in our homes unless we're going to the grocery store or doctor or something like that. So getting that speaker is going to be a little bit of a problem for who knows how long. The COVID thing is not going all that well here in Canada. In fact, it's really not going well at all. So so this radio is going to go away for a while. That's what's going to happen. Too bad. Okay, so thanks a lot for watching this series to this point, and who knows when I'll pick it up again.